What's up everyone, welcome to another video, and today we are going to continue with exercise 7.2. We are left only with 3 sums, question number 8, 9 and 10. So we are going to solve question number 8, 9 and 10 today. So without wasting any more time, let's get started. So we'll start off with question number 8. So if you can look into question number 8, there are 2 points given, point A and point B, and there is another point P in the middle such that AP is to AB is 3:7. That means this part, a part between A and B, that is AP, and the whole part, that is AB, are in the ratio of 3:7, and we are given the coordinates of A and B, and we have to find the coordinate of P. So coordinate of A is given as -2, -2, coordinate of B is given as 2 and -4. So we have considered the coordinate of point P as x, y. Now let us write what is given. It is given that AP is to AB is 3:7. That means AB, which is the full part, is actually 7, and AP is only 3 out of the 7. So if AP is 3 out of the 7, that means PB is how much? If this is 3 and this whole sums up to be 7, then this part will be, this PB will be 4. Hope you understand. 3 and 4 will add up to be 7. So if AP is to AB is 3:7, in that case AP is to PB will be 3:4, right? So therefore we must have AP is to PB equal to 3:4, right? So now we have the ratio AP is to PB, that is, in the section formula M1 and M2 we have now. M1 is 3 and M2 is 4. Now we can use the section formula to find the value of x and y in P, right? So let us try and do that. So by using section formula, where the ratio M1 is to M2 is equal to 3:4, we have, what can we have? We can have the value of x. X is M2 x1 plus M1 x2 by M1 plus M2. So what is M2 here? M2 is 4, M1 is 3. So let us write 4, and x1 is -2 plus M1 is 3 into x2. X2 is 2. And at the bottom we have 4 plus 3 or 3 plus 4, whatever you add, right? So it is -8 plus 6 by 7, which gives us -2 by 7. So we have x as -2 by 7. Now let us try to find out y. Y will be equal to M2 y1 plus M1 y2 by M1 plus M2. In the similar way, we can write here 4. Y1 is this one, -2 plus M1 is 3 is to Y2 is -4 by 4 plus 3. So we have -8 here, plus minus minus, 3 4s are 12, and we have 7 here. So it is -20 by 7, and hence we have found the value. X is -2 by 7 and y is -20 by 7. Very simple. You just need to find the ratio. Once you can find this ratio, which is also very simple to find out. So once you find this ratio, you can usually use the section formula and find the value of x and y. So now we have the coordinate of P. So therefore coordinate of P is, this is our x, -2 by 7, and this is our y, -20 by 7. And that's the end of the sum. So let us move on to question number 9. So if you look into question number 9, what it is given, that there are 2 points A and B, and both the coordinates of A and B are given. A is -2, 2 and B is 2, 8. We have to find the coordinate of the points which divide the line AB into 4 equal parts. So if a line has to be divided into 4 equal parts, there must be 3 points in the middle. So suppose we have P, Q and R, which divide the line into 4 parts. First part, second part, third part and fourth part. Okay, so we have 4 parts and all are equal parts. So if all the parts are equal and we have to find the ratio, then what will be the ratio? It will be 1:1:1:1:1. Since all parts are equal, so the ratio will be 1:1:1:1. So now that we have the points A and B and we have to find P, Q and R, we can find it easily using section formula. Now there are two ways we can find. One is the simpler method, one is a little bit complex, not complex, a lengthy method. So what is the complex method? Let's look into that first. Suppose I want to find the point P using A and B. So how do I find? For P, I need to find the ratio of AP is to PB, right? So AP will be 1 and this will be 1 + 1 + 1, 3. So the ratio will be 1:3. So using this ratio and using A and B, I can use the section formula and I can find the value. That will be the complex part. Then I can do the same for R and Q also. But let's not do that and let's use a simpler process. And the simpler process will be, let us first try to find out Q. And why I am doing that? Look, as AB is divided into 4 equal parts, Q will be the midpoint of A and B. If you look closely, A to Q is 1, 1, 2 parts. And Q to B is also 2 parts. That means this part and this part are equal. So here both come out to be 2, here both come out to be 2. And 2:2 means 1:1. That means Q is the midpoint of AB. If Q is the midpoint of AB, we can use a simpler section formula. Let's look into that. So let the 3 points that divide AB into 4 equal parts be P, which is x1, y1, Q, which is x2, y2, and R, which is x3, y3. So that is what we have for the 3 values. Now let us move into more details. So here Q is the midpoint of AB. For midpoints, what is the section formula we have? If we have to find midpoint, it will be x will be x1 plus x2 by 2 and y is equal to y1 plus y2 by 2. I hope you have seen this in your book. These are the two formulae that we use to find out the values of midpoints, means the coordinates of the midpoint of a line. So as it is midpoint, we can use these values, which makes it very simple. So therefore, since Q is the midpoint, what will be x2 and what will be y2? So therefore, x2 will be equal to this coordinate of x and this coordinate of x, means x coordinate of A plus x coordinate of B by 2. So we have -2 and 2. So it will be -2 plus 2 by 2, which is 0 by 2, that is 0. Similarly, what will be y2? Y coordinate plus y coordinate, that is 2 plus 8 divided by 2. So it is 2 plus 8 is 10, 10 by 2 is 5. So therefore the coordinate of Q is 0, 5. So we have found the coordinate of Q and Q has become 0, 5. So we can write it here 0 and 5. So one point we have found out. Now let's move on to the remaining ones. Now let's try to find out P. So in order to find out P, we will not take AB into consideration. Now that we have Q, we will take Q and A. So let's take A and Q and try to find P. So how? Again the same thing. See the ratio between AP and PQ. AP and PQ is 1:1. That means P is the midpoint of AQ. So you can write this if you want, that since AP is to PQ is equal to 1:1, therefore P is the midpoint of AQ. Again we can use the same x1 plus x2 by 2, y1 plus y2 by 2 in case of P. So therefore P is x1. So x1 will be equal to which 2? Coordinate, x coordinate of A plus x coordinate of Q. -2 plus 0 by 2. -2 plus 0 by 2. That is -2 by 2, which is -1. Similarly y1 will be y coordinates -2 and 5. 2 and 5. So 2 plus 5 by 2, which is 7 by 2. So therefore coordinate of P comes out to be -1, 7 by 2. Okay, so here we have P as well, -1 and 7 by 2. We have the coordinate of P. Let's move into the coordinate of R and let's see how that takes place. Again we will use the same method. This time we will take Q and B and we will have R as the midpoint. So since we can write again QR is to RB is equal to 1:1, therefore R is the midpoint of QB. So therefore x3 will be, get the x coordinates, 0 plus 2 by 2, that is 2 by 2, which is 1, and similarly y3 will be, y coordinates 5 plus 8 by 2, which is 13 by 2. So therefore the coordinate of R comes out to be 1, 13 by 2. So here again we have the coordinate of R, which is 1, 13 by 2. So that's how we find the 3 points. Very easy, simple sum, little bit lengthy because we have to find 3 points. But each step is very easy. You just have to find the midpoint and use this formula, x1 plus x2 by 2, y1 plus y2 by 2, and you get the values. So that's how easily we can solve question number 9. Let's move into the last sum, that is question number 10. If you look into question number 10, what is given here is that there are 4 vertices, all the vertices are given, 3, 0, 4, 5, -1, 4 and -2, -1. These are taken in an order, only in one direction. The 4 coordinates of the vertices of a rhombus are given. We have to find the area of this rhombus. Now in the hint you can see it is given, the area of a rhombus is equal to half into product of the diagonals. So in order to find the area, we need to find the diagonals first, then we can find their product, multiply it with half, and we can get the area. So that means we need to find the diagonals first. So diagonals means I have given here a name, A, B, C and D. So we need to find AC and we need to find BD. If you can find AC and BD, we can get the 2 diagonals, then we will use the formula to find out. So let the 4 vertices be A 3, 0, B 4, 5, C -1, 4 and D -2, -1. These are the 4 vertices we have. Now let us look into the diagonals. So therefore the diagonal AC will be what? Distance formula, x2 minus x1 whole square plus y2 minus y1 whole square, x2 minus x1 whole square plus y2 minus y1 whole square. This is our distance formula. So let's apply it for AC. So we have -1 -3, -1 -3 whole square plus 4 minus 0, 4 minus 0 whole square. So it is -4 whole square plus 4 square. So that is 16 plus 16, which is 32, or you can write 2 into 16, which is 4√2. So the diagonal of AC is 4√2. Let's find diagonal BD. That is BD will be equal to, again same formula, x2 minus x1, y2 minus y1. So BD, so we have -2 minus 4 and here we will have -1 minus 5. Okay. So what we have here, it is -6 whole square, again this is also -6 whole square. So it is 36 plus 36, which you can write as 2 into 36, that is 6√2. So therefore area of ABCD, that is the rhombus, will be equal to half into product of the diagonals, that means product of AC and BD. So what is AC? AC is 4√2 and BD is 6√2. So we can go for half into 6 4s are 24 and √2 into √2 is 2. So if we cancel these, we will get 24 square units. So that's how we get it, 24 square units. You find the diagonals using distance formula. Here we will not use section formula, not required. So we will use distance formula, use the hint that is given, area equal to half into product of diagonals, and we can find the area of the rhombus. So I hope you understood this one. I hope you understood the previous sums. If there is any confusion, make sure you comment down in the comment section. I will be there to help you out. So thank you everyone for watching, and until next time, cheers.